Hi friends, our new chapter is all about alternating current or which is commonly known as AC current. Now, why do we need AC currents? Because AC voltages can be easily converted from one voltage to other by means of transformers, and electrical energy can be easily transmitted over long distance, and that too economically when we use AC current. And so because of some reasons we are normally using AC currents in many of the electrical appliances these days. Now, we know three main circuit elements till now. One is a resistor, another is a capacitor, and another is inductor. We have studied so far these three things, right? Now, let us see how these elements react when they are subjected to AC voltage. First, we'll start with resistor, and then we'll try to cover these both also. Okay, first, consider a simple circuit where you apply AC voltage to a resistor of say resistance R. Now, say this is a varying voltage, right? We are giving a voltage which varies sinusoidally. I mean, say the voltage, external voltage given is Vm sin omega t, where Vm will be the maximum value, right? Because sin omega t varies from -1 to 1. So Vm will be the maximum voltage, or I can say it is the amplitude of oscillating potential, and omega is the angular frequency of this oscillation, or I can say omega is 2 pi by time period of one cycle. Hope everything is clear till now. So this is our voltage, external voltage. How about current? We know by Ohm's law that V is equal to IR, right? Here by Kirchhoff's law, at across these 2 points, the EMF is V, right? Vm sin omega t, and that should be equal to IR, because the sum of potentials around a loop should be zero, right? By Kirchhoff's laws, and that should be equal to I and R. So what can I get from this? My I is nothing but Vm by R sin omega t. So my current is also varying sinusoidally. I can write this as Im sin omega t, where Im is nothing but Vm by R, or Im is nothing but the current amplitude. Got it? Here in this case, note that the current and the voltage, this one, they reach their highest values at the same time. When voltage and current reach the zero and maximum and minimum values at the same time, then voltage and current are said to be in phase with each other. And let me tell you one more thing. See here, current is given by Im sin omega t, right? And this varies from -Im to +Im, right? So when I take an average over a cycle, then what happens? My average current turns out to be zero, because the least possible current is this one and maximum is this one. And so on an average, the current is zero. For some part of a time, current is in one direction, and for some other part of time, current is in the opposite direction. Hence, the average current will be zero. But note that the average power is not equal to zero. So the energy dissipation will still be there, because what is power? Power is I square R, right? And I square, whether the direction is positive or negative, it will always be positive. I square is always greater than zero. Hence, there will be power loss always, or power dissipation, energy dissipation. So P is equal to I square R. I want to calculate the power. So at some instant, I don't know, the current will be Im sin omega t. So I square will be I square sin square omega t. And I can write this as, this is my instantaneous power at any time instant, say t. Okay. Now I'm interested in average power. What will be it? Say P is power. Whenever you put a bar over any constant, it symbolizes that is the average of that quantity, that particular quantity. So I'll write this as this one. And whenever you give these kind of brackets, it means that you have to take the average of quantity which is in between them. So I'll write I square as Im square r sine square omega t. This is my average power, right? And we take average for only those quantities which vary. Here Im is a constant, r is a constant, so I can take them out. I'll take them out and take the average of sine square omega t. And there is a mathematical equation or identity which says sine square theta is nothing but 1 minus cos 2 theta by 2. So from that I can write sine square omega t as 1 minus cos 2 omega t whole divided by 2. And 2 is also a constant. So Im square r by 2. And here inside the brackets I have 1 and cos 2 omega t. 1 is also a constant. So finally I have to take the average of only cos 2 omega t. Everything is fine. So what is the average of cos 2 omega t? Even this varies from -1 to 1. So the net average will be 0. And finally I'll be left only with the Im square r by 2. This is the average power. So average power is Im square r by 2, where Im is the maximum value that current can have, that is current amplitude. Well, if I had a DC source, I would have expressed the power as P is equal to I square R. So here can I express it? Yes, you can. For that you need something called as IRMS, which is nothing but IRMS is the root mean square current, or in simple terms you can say that is the effective current, it is the representative current. So if I had IRMS, I can express my average power in terms of IRMS square into resistance, right? So I know what is the average power. It is Im square r by 2. When I equate this to IRMS square r, what will I get? I'll get that IRMS is nothing but Im by root 2. So this is the IRMS. Root mean square current is nothing but 0.707 times maximum value of the current which is varying. Hope everything is clear till now. Similarly, you have something called as RMS voltage, which is nothing but current RMS into the resistance. And since IRMS is nothing but Im by root 2, right? Similarly, we have VRMS as V by root 2. That is Vm by root 2. The maximum voltage by root 2. This will be the VRMS. Now let us solve a problem. It's not exactly a problem, but to give an idea, when the power company says that they are giving a voltage of 220 volts or 120 volts to your house, they mean that this is the RMS voltage. Okay, so when you want to calculate the highest voltage possible, that is Vm, then what you should do? 220 times root 2 will give you the answer, that is something 311 volts or something. In India it is 220, that's why it's so. And similarly, when you buy a bulb, say it is written on the bulb as 100 watts. This power is also the average power. So if I want to calculate the resistance of that particular bulb, what will I do? The average power is given by IRMS square into R, right? It can also be written as VRMS square by R. And so I know the VRMS, it is 220 whole square by resistance. I don't know, I want to calculate it. Will be equal to 100. That is the average power. From this, I can get R as 484 ohms. And that's it. We have one more small topic left for this video. That is phasors. What are phasors? Phasors are nothing but some rotating vectors used to represent these varying quantities. These quantities which vary sinusoidally. Now, why do we need these phasors? Because till now we have dealt with those situations where voltage and current were in phase. I mean, they were reaching their respective maximum values and minimum values at the same time. But when you have an inductor or capacitor in your circuit, then they'll have some phase difference, or they'll not reach the maximum values, their respective maximum values at the same time. And in those cases, phasors are very handy to analyze the situation. Uh, I'll tell you how to read them. Say if you have a voltage that varies sinusoidally in this way. This phasor represents the voltage, and this is a phasor which rotates anti-clockwise with the angular velocity omega. So if it starts from this initial position, the position of this phasor will be this one. At what time? At time t. So this will be the angle covered, and this is the phasor at that particular instant. So when I give a dotted line, it will be something here. So this is the value of that phasor at omega t. Say this is complete cycle, this is pi, this is 2 pi, and this represents the voltage which varies in this way as a sine function with omega t. And this vector you have, right, the perpendicular component or the vertical component, what will it be? It will be Vm sine omega t if the magnitude of this particular vector is Vm. So whatever phasor you have, the magnitude of it will be the maximum value of that particular varying quantity, and the perpendicular component or the vertical component will give its instantaneous value. The phasor will be rotating with the omega angular velocity in anti-clockwise direction. This is clear. Now, if I want to represent Im of the previous situation, that is purely resistive circuit, in this phasor diagram, you know that the voltage and current were in the phase, right? So my current will be something like this along this one because they are in phase, and so my current will be something like this here. Even that has the same time period, but the amplitudes will be different, right? Say this is my current value, so the perpendicular component will be this one, which is nothing but Im sine omega t, or Vm by R sine omega t. And these two vectors are parallel here because the voltage and current are in phase here. Otherwise, they wouldn't have been. You'll understand it better when you deal with some circuits where you have capacitors and inductors involved. Actually, I'm discussing these phases in this video because in the next video, I'm going to discuss AC applied to inductor and capacitors as well. And be clear with this. Hope you enjoyed this video. Keep watching. Bye.